commented, you saw this on the ACT. What on earth is a trig identity?
Why don't you tell us?
What's an identity mathematically? Okay, what's the identity property? Like if I said, the multiplicative identity was 2 times 1 equals itself. Identity means you get yourself back. But in this case, an identity is something that's true for any number you put in for the variable. It's always true. So an algebraic identity would be something like,
oh my God.
Cody, you're on video. Okay. So that's an identity. Because no matter what number I put in for x, it's going to be true. It's going to be equal. If I put 2 in for x, they're equal. If I put 50,000 in for x, they're equal. In our case with trig identities, it's true for any angle you could put in it. Any angle measure, they would always be true. Yes, degree or radius, yes, will be true in either one. Yep. So we're going to see identities where we have, it's going to help us with any angle we could possibly work with. So just in case, they are true for any value. Okay. There are, and by the time we're done, there's probably 30-some identities we're going to learn to use. However, you only have to memorize these 8 we did today. These are the 8 fundamental identities, and they are critical. They show up all over the place in trig and calculus. We keep running into them. So these 8 are super important, and they are true for any angle. Okay, I'm going to teach them to you in groups because they kind of go together. You don't have to know them by these groups, but I think it helps. The first 3 identities are what we call the reciprocal identities because they tell us about which trig functions are reciprocals of each other. Now, we already know this, I hope.
No.
Which trig function is the reciprocal of sine? Cosecant. And actually, let me pause a minute. Okay, so I just listed over there the stick your rotten crazy by xylophone, how you know your trig functions are in terms of x, y, and r. So sine is a reciprocal with what other function? Cosecant. Sine and cosecant are reciprocals. So we also write that as an identity. It doesn't matter what size angle you have, whether you're at 30 degrees, 60 degrees, or 4,520 degrees, they're always going to be reciprocals. Okay, I'm going to write it in terms of we usually have a cosecant. We usually want to change cosecant into sine. So cosecant would be the reciprocal of sine. It would be 1 over sine. You can write it the other way. You can write it sine as 1 over cosecant, but you'll hardly ever use it that way. But it can be written in either form, but this is the form that's most common for us by far. Okay, so if that's true, what's the next one got to be? Yeah, secant's equal to 1 over cosine. And cotangent is 1 over tangent then. Or tangent's 1 over cotangent. It works either way. Okay, so those 3 are the reciprocals. I am numbering them because when I'm teaching them, it's easier for me to say, look at number 5 or look at number 2 or whatever. You don't have to know them by number. Okay, the next 2 are called the ratio identities. A ratio means you have what? Something over something, yeah. Okay, these 2 pertain to tangent and cotangent. And once you see it, I'll bet you'll remember it from last spring. Tangent's equal to a trig function over a trig function here. And to get you to see why, I want you to look at your rotten crazy xylophone. Yeah, Colin. He said sine over cosine. How did you come up with that? He remembered it. Yeah. Colin's right. Yeah, tangent sine over cosine. Because if tangent's y over x, if I do sine, sine's y over r. X over R, what happens when you flip that over? The R's will cancel, you'll be left with Y over X. So
I bet 5 is going to be,
5 is for cotangent.
so it's going to be cosine over inverse.
Bingo, yeah, it's just this upside down. It's cosine over sine. Yes. Now, okay, how do you keep those straight in your brain when you're trying to memorize them?
Switch over from,
I always remember cotangent starts with co, it has cosine on top.
Wait, I got a question. Just put those numbers that are letters over R.
Well, I went, sine is Y over R, cosine is X over R, and so then when you flip it over, the R's would cancel and you'd be left with Y over X. So it would work. So those two are very handy. Most of the time as we work problems, probably 85–90% of every problem you'll ever work, you'll want to change it into sines and cosines because sine and cosine are related to all the other trig functions. So you're going to, a lot of times you have a problem with a tangent in it and you're going to go, I need sines and cosines. So you're going to use number 4 and 5 a lot so you can get it into something that's easier to work with. Okay, so then the last three, anybody have any recollection?
Oh, I remember. I wasn't here.
They're called the Pythagorean identities. Okay, so it probably means they use what?
You're adding and squaring. Like actually add, so like something with something.
Yeah.
Plus something.
They do indeed. They come from the Pythagorean theorem. Okay, and I will give you, yes, Simone is correct. He said sine squared plus cosine squared equals 1. You've learned it. Oh, okay. I thought you guys knew it. Okay. Do you all remember our handy little triangle with x, y, and r? What did the Pythagorean theorem say about that triangle? R squared. Yeah. Okay, well then, mathematicians love to play around with equations and formulas and see, oh, let's change something and see what happens. So somebody said, hey, I want to make it equal to 1, so I'm going to divide by r squared and make it become a 1, but then, of course, I have to divide everything by r squared. Okay, ever seen x over r anywhere before?
No.
X over r is cosine, and it's squared, though, so we'd have to write cosine squared. Y over r is sine, and that equals 1. So that is the number one most important identity. As far as where we use it on down the road in math, that's the one that comes up the most. It's the only one that actually connects sine and cosine to each other. Yeah.
What if you take away the square?
Thank you. Okay, yes, what if you take away the square? Can I just square root each of those and say cosine plus sine equals 1?
No.
Why?
Because it's square root.
Yeah. Oh, let me ask you this, guys. I've done this many times before. 1 plus 2 equals 3. But does 1 squared plus 2 squared equal 3 squared? No. That is not true anymore. You can't just take away the squares. So this identity is only true if it's squared. You cannot use that identity with any other powers. It has to be squares only.
So, where do we use it?
I'll get to that. I got 2 more, and then I'll start showing you why we care. So it takes a minute. And it doesn't matter which order you write that in, cosine squared plus sine squared or sine squared plus cosine squared, either is fine. Okay. However, I want to point out, you are legally allowed to rearrange any of these with algebra. You pretty much won't on the first 5, but on this one, you'll use other versions of it. You may find it helpful to go, oh, cosine squared would be equal to, if I subtract sine squared to the other side, 1 minus the sine of theta squared. It is legal to rearrange these and move things to opposite sides of the equal sign. That is a legal thing to do. The math police will not come after you. It's legal. Yeah. It's a secret agency, I can't tell you.
If it's your family.
Okay, so it's a secret agency.
Trust
You
me.
just told me.
Trust me, it's not my family. I have not inspired them. They're all good at math, but nobody is passionately in love with math.
That's probably a good thing. That makes me
I've tried really hard, but I've failed.
Yeah. No, if you probably didn't bug them so much about it, they probably would have liked math.
Well, they don't mind doing math. They just think I'm a little obsessive. It's okay. So, you'll notice this time I took the same problem, but this time I divided them all by x squared. What will I get?
You're gonna subtract a y over, and you're gonna get.
X over x is 1. What's y over x? Tangent. So that would be tangent squared. And r over x is secant. So I would have it equals secant squared. Okay. By the way, thou shalt write an angle with every single trig function. We don't drop the angles off. There's a theta and x. I don't care. Pick your letter, but there better be a variable there. That is a big deal.
So if you have secant squared, could you do like the number?
Would you just like rearrange the tangent?
You could, yeah, then sub in place of that secant squared, you could sub this 1 over cosine, you do 1 over cosine squared then. We're going to get to that in a second. Yeah. So yes, you can interchange these and substitute one of them into another one. That's where we're going with all this.
I'm pretty sure this is like the best biology.
Yeah, this is totally cool. It's like the best thing ever.
If you wonder why your family hates shrimp.
All right, last one. I divided by r, I divided by x, so I suppose I better. What happens if I divide them all by y? Then what will I have? Cotangent squared plus 1, and r over y is cosecant squared. Okay, when I write this up here as number 8, I'm going to switch the order, and I'm going to write it as 1 plus, because I want you to see the pattern. What's the difference between number 7 and number 8?
Cotangent and cosecant.
Yeah. 8 is simply take set number 7 and put cos on it. Tangent becomes cotangent, secant becomes cosecant. So if you can learn 7, you can learn 8. When I actually have you write these out for me, 7 and 8 most missed. We will use them the least. So we don't learn them as well. We use them some, but they aren't used nearly as much as the other 6 will be used. Okay. There are 3 other little ones, which, by the way, now that I've got these up here, you know that yellow sheet I gave you that has the special angles on it, and it's got all these identities on it? You're going to live and die with that yellow sheet this chapter. If you have managed to lose it, there's plenty more back there on the wall. But in particular, it's not that bad. Okay. You do not have to memorize all the rest of them. No, just you have to know the 8. Those 8. The rest of them I'll give them to you.
Take that negative off. Take that negative off.
Okay. There are 3 little identities that are kind of handy.
Do you need to stop now?
I wanted to finish this. I'll be about 15 minutes when I get this done. There are 3 little identities that tell you what to do if you have a negative angle, because for the most part, we don't want negative angles. So they're written right underneath the 8 fundamentals on your yellow sheet. But it actually, I can now explain to you why we get the answer we get. Y'all remember even and odd functions? Even function said if you put a negative x in the function, you got the original function back again. And odd functions said if you put a negative x in, you ended up with a negative of the original. Okay. Even functions were symmetric to the y-axis. That you may or may not remember. Anybody remember what odd functions were symmetric to? Origin. They both start with O. Okay. Well, now I want you to think about, what the graphs of these 2 trig functions look like. Sine is a wave. What's it symmetric to? Y-axis or origin? I got a vote for origin up here. Is it reflecting across the origin? Yeah. Sine is an odd function. So therefore, since sine is odd, when I have a negative angle inside it, where is it saying I should put the negative? Out front. So sine is equal to a negative sine of the positive angle. You just pull the negative out front if you have a negative angle on a sine. Alright, so if I did cosine, okay, cosine started at the peak and did its wave thing. What's that symmetric to? That's the y-axis. It's flipped over the y-axis, so therefore it's an even function. Which means when it has a negative angle, what do I do with the negative? I just get rid of it. It just becomes cosine of the positive angle. It's the same thing on a cosine. And then, last but not least, our good friend tangent. You actually only really need the one, but I could do it more than that. But it's got what kind of symmetry? Origin. So it's odd. Therefore, if it's odd, we pull the negative out front. So the only one that just the negative disappears is cosine. And then, of course, cosine's reciprocal is secant. So cosine and secant, the negative just goes away. On the other four, you pull the negative out front. So don't see that a ton, but occasionally that's handy. If you have a negative angle, you don't want to deal with a negative angle, you use those rules. Okay, so now we can work problems. We need to stop the video.